Hi everyone. So today we are going to solve this easy level problem called implementing the queue using stacks. So we have a stack and we need to build a queue out of it. So these are all the normal operations which a stack has to do. So here's the the challenging part. So uh, we must do all these operations in amortized time. So all these operations should take O of 1. Like it might take O of 1, but can be amortized to O of 1. So let me explain what is that. So performing n operations will overtake. So it will take overall. Okay, so I'll explain that using an example. So I'll come back to that later. So what is amortized time? So yeah, basically we just have uh, to implement a queue using stacks. So we are given two, so we can use only two stacks. So let's see how we can do that. So okay, so uh, what we do, we have two input stacks, and this is the queue. So when we do a peak, one should come, or when we do a peak or a pop, one should come. So uh, so stacks means like, yeah, so these are the stacks. So what we do here is when we are made to push, okay, we need to implement the push, just call it p. So we will get one letter called, we'll get anything, push of x something, one integer will get. So when we get that integer, we need to just push it here. So for push, we just need to add it over here, 1, and again we'll get a 2, then again we'll get a 3, then again we'll get a 4. So now when we have to pop it, we need to check the output stack. If we have to peak or we have to pop, we need to check the output stack. If the output stack is empty, we move everything from this stack to this stack. So how we move everything from this stack to this stack? So in this case, it is empty. So we just pop everything. So we pop 4, okay? We pop 4 and we put it here. 4 came here. Next, we pop 3, we pop 3 over here. Next, 3 will come here. Next, we pop 2, 2 will come here. Next, we pop 1, 1 will come here. So now we have it. So now over here, we can just pop this element, the very first element from the output stack. So this condition is when the output stack was empty. So initially the output stack was empty, we did all this. So what is the scenario where the output stack has numbers? So in that case also, it's very simple. We just need to pop it up, or pop or peak, whatever. So I'll write the pseudocode for this one. So for popping, so if you want this, yeah, so if you want to pop something, so pop, okay. So first thing what we do, we check the output stack. So if output stack dot is, so if it is not empty, like for example we already have this one, right? If it is not empty, so like in this case it's not empty, so we just pop it. Oh my god, sorry guys. So we just pop it. We say uh, out output stack dot pop. So else, if it is empty, we just move everything over here. So we move, I'll just write it as, hmm. So I'll just write it as move move all the elements from input to output stack. So this is for pop, and then sorry. So this is for pop, and then for push, like I said, we just push it. We just do a normal push into the stack. That's it. Okay, push. And next for peep, for peak, it is just the same. So we do the same thing. If output is not empty, uh, we return output stack dot peak. So if we do peak, one will come out. Else we move everything from input stack to output stack, and we just pop it. Sorry, I forgot to write pop here. So we move. So if it's a pop, we move everything from input stack to output stack, and then we pop it. And same thing over here, peak also. Uh, if it is empty, we move everything from this input stack to output stack, and then we peak. So if we do a peak, the same code comes, and then in the end it is peak. So we get one as the output, so which is one. So and then to check if it is empty, we just check if both of them are, if both the input and output stack is empty, we it is an empty. So let's put that code, whatever the pseudocode I have written. Uh, Let me put this in a different one. Yeah. Okay. So now let's put this here and just okay. So one second. I'll just remove all this code. I'll just keep these both. And just, yeah. So we just put this one. So first thing, like I said, push. So if we do push, what was the okay? So if we do uh, just write public int push, so push should not return anything. So why push? We just do, so we push everything to this input stack. So input dot push x dx. So next this one push it, next pop public void pop. Yeah, it's not void. I should return an int. So next, when we do a pop, so first thing we should check if this so we check if this output stack is not empty. If it is already containing numbers, we just pop it off. So if output dot is not empty, is not empty, so, so if this output is not empty, we pop it off. So return output dot pop. So else else we move everything from input stack to output stack, and then we pop it. So if it is, so if it is now if it is empty, move everything from input to output. So uh, move everything from input to output. While input dot is not empty, not empty, input dot pop, whatever gets popped, we push it to output dot push output dot push. So move everything from input to output, and then we do output dot push. Or our from input we get, we do output dot push. When input is not empty. After doing this operation, we return out output dot pop. So next thing, we do the same thing for push. I mean peak. PK. So output dot PEK. Do output dot PEK. Next, for empty public is the name of the method. We just put this one. So if both of them are sizes are 0, we return true. That is they are empty. Else we return false. So that's it, guys. That's done. Let's submit. Okay. Yeah, guys. So that's it. That's just how we implement a queue using a stack. Thank you for watching.